In this video, I'll be explaining question 2 of homework 2. So the question goes as follows. We are given an input signal x1. We pass it through a noisy channel and we get an output x2. Then we pass x2 again through a noisy channel to get x3, and this goes on till we pass the input xk through the noisy channel to get the output xk plus 1. And we are also given that probability of x1 equals to 0 is 0.2, probability of x1 equals to 1 is 0.8, and we are also given that for all k from 1 to n, the following probabilities hold, which is that probability of xk plus 1 equals to 0 given xk equals to 0 is 0.6, probability that xk plus 1 equals to 1 given xk equals to 0 is 0.4, probability for xk plus 1 equals to 0 given xk equals to 1 is 0.3, and similarly probability for k plus 1 equals to 1 given xk equals to 1 is 0.7. And we need to find out probability that x2 equals to 1, probability that x3 equals to 1, probability of x1 equals to 0 given x3 equals to 1, and limit n tends to infinity, probability of xn equals to 0. So starting off with the first part, which is probability that x2 equals to 1. So this will have two cases. The case 1 will be that we pass 0 as an input signal, which is x1 equals to 0, and we get x2 equals to 1. Or the second scenario could be x1 equals to 1 and x2 is equals to 1. So for the two scenarios, let's consider the first scenario. In this case, the probability that x2 equals to 1 will be probability of x2 equals to 1 given x1 equals to 0 times probability that x1 is equal to 0. And for the second scenario, we'll have probability of x2 equals to 1 given x1 equals to 1 times the probability that x1 equals to 1. So we substitute the values that are given in the question. So probability that x1 equals to 0 is given as 0.2, probability x2 equals to 1 given x1 equals to 0. So from here we can see that this will be 0.4, and probability of x1 equals to 1 is 0.8, and probability of x2 equals to 1 given x1 equals to 1, from here we can see it's 0.7. So we get the final answer as 0.64. Now in the second part, we need to find the probability that x3 is equal to 1. So again, this will have two scenarios. The input signal x2 that is passed through the noisy channel, it can be either x2 can be 0 or it can be 1. So considering both the scenarios, the probability that x3 equals to 1 will be probability x3 is equals to 1 given x2 equals to 0 times the probability that x2 is equal to 0 plus probability of x3 equals to 1 given x2 equals to 1 times the probability that x2 is equal to 1. And we can see that for these two values, probability x2 equals to 0 and probability of x2 equals to 1, we have already calculated these in the previous part, which is part A. So we can directly substitute these values. Probability of x2 equals to 1 is 0.64, and probability of x2 equals to 0 is 1 minus 0.64, which is 0.36. And for these probabilities, probability of x3 equals to 1 given x2 equals to 0 and probability of x3 equals to 1 given x2 equals to 1, these are already given in the question, so we can directly substitute these and we get the final answer as 0.592. Now for the third part, we are given that we need to find probability of x1 equals to 0 given x3 equals to 1. Now from the previous part we already know the probability that x3 equals to 1 is 0.592 and probability of x3 equals to 0 is 1 minus 0.592, which is 0.408. So we can simply use Bayes theorem, which according to which we'll get the given probability x1 equals to 0 given x3 equals to 1 as probability of x1 equals to 0 and x3 equals to 1 divided by probability of x3 equals to 1. Now the numerator can further be written as probability of x3 equals to 1 given x1 equals to 0 into probability of x1 equals to 0. So we are simply using the Bayes theorem again, which is that probability of x1 probability of x3 equals to 1 given x1 equals to 0 can be written as probability of x1 equals to 0 x3 equals to 1 divided by probability of x1 equals to 0. So we can multiply this denominator with this thing, and the value for this probability of x1 equals to 0 and x3 equals to 1 can be substituted here to get this thing. Now if we look at this whole equation, this whole thing, we can see that probability of x1 equals to 0 is already known to us, it's given in the question, and probability of x3 equals to 1, this is something we found out from the previous part, so we can simply substitute these values. Now for this part, so we can again we will have two cases. First will be probability, like this can go from x2 equals to 0 or x2 equals to 1. So let's first consider x2 equals to 0. So in that case, probability of x3 equals to 1 given x1 equals to 0 can be written as probability of x3 equals to 1 given x2 and x1 equals to 0 times the probability of x2 equals to 0 given x1 equals to 0. And the second scenario will be probability of x3 equals to 1 given x2 equals to 1 and x1 equals to 0 times the probability x2 equals to 1 given x1 equals to 0. Now we can simply plug in the values because these are already given in the question, and when we finally calculate, we will get the answer as 0.1756. For the last part of this question, we have to find limit n tends to infinity probability of xn equals to 0. So here we'll consider that this probability as p, and we know that since n tends to infinity, the probability of xn equals to 0 limit n tends to infinity will be equal to probability of xn minus 1 equals to 0 limit n tends to infinity. And we also know that the probability of xn equals to 0 can be written as probability of xn minus 1 equals to 0 into probability of xn equals to 0 given xn minus 1 equals to 0 plus probability of xn equals to 0 given xn minus 1 equals to 1 times the probability that xn minus 1 is equal to 1. So adding up these two scenarios, first we'll substitute p at the places. So for limit n tends to infinity, this will be equal to p, this thing will be p, this we already know from the question, this will be 1 minus p, and this we are already given in the question. So we can solve this, and finally we get probability as 3/7. So this will be the final answer.